Today we are going to combine lesson 1.4 and 1.5. So we're going to start with lesson 1.4. This is adding real numbers. So remember in lesson 1.3 we talked about the fact that real numbers are going to be any rational numbers, irrational numbers, and then under rational numbers you can have the whole numbers, the natural numbers, and so you have to be paying attention to that, and then the integers. So we're going to go over some of the vocabulary that goes with it, and we're going to go pretty quick because this should be review from last year, and you're going to get a lot of opportunities to practice it. So the additive inverse, whenever you hear me say that or you read it, just means opposite. So if it was 2, negative 2. If it was negative 4, positive 4. So an example of that, 2, negative 2. And what you're going to notice with the additive inverse, the opposite, is that whenever you add them, you should always have 0. 2 plus negative 2 equals 0. That should always happen with your opposites. The identity property of addition, you just have to memorize this, and all it is that when you add 0, it doesn't change. So if I add 2 plus 0, I just have 2. Okay, and then now we're going to go into the rules. If we're adding integers, or any real numbers actually, with the same sign, you're always going to keep the sign the same. I think some of you have heard this as same sign sum, which means keep the sign the same, add it. And this is going to work with positives and negatives. So if I'm adding 2 positives, I add them, it stays positive. If I'm adding 2 negatives, I add them, it stays negative. So let's just do a quick example of those. Something like 2 plus 3, as you all know, is 5. Negative 2 plus negative 3, keep the sign the same, add them up. I have a total of 5 negatives. This is where a lot of students get confused with the rule between adding and then when you're subtracting another negative and when you're multiplying. So all you have to be aware of here is that there's an addition sign between 2 negatives. Add them up, keep them negative. Okay, when we're talking about adding numbers with different signs or opposite signs, this one's the one that you have to be a little more aware of. What you're going to do is find the difference, and everyone should know difference means subtraction, of the numbers. Okay, you're not worried about the sign when you're finding the difference. All you're looking at is just what is the difference between those 2 numbers. Then you're going to take your sign, your positive or your negative, from the number with the greatest absolute value. And again, if we're talking about that, all I mean is the number that's larger if you weren't looking at the sign of it. So both, if they were both positive, which one's bigger? And then the one that's bigger is the one that you take the sign from. So quick example of that. -2 plus 6. I have opposite signs and I'm adding. Difference between 6 and 2 is 4. 6 is the larger absolute value. This would be 2, that would be 6. So I take the positive sign, so my answer is positive 4. If I had 2 plus a -6, now I'm looking, same thing. Difference between 2 and 6 is 4, but absolute value 6 was greater, so I bring the negative over with the 4. If you have questions about that, let me know when we work on it in class. Okay, you're going to be asked to evaluate. You've already had a little practice with evaluating, so this should be the same thing, just applying the rules we just discussed right now. The biggest thing that I want you to be aware of with evaluating is that you're always going to use parentheses. Around the value you are evaluating with, or you're plugging in, however you want to say that. Okay, it's really important you do that because it's going to help you in the future just to get used to that when we have a lot of different things going on with exponents, positives and negatives, and different things. So just get in the habit of doing that now. This is actually example 4 in your book. And it tells you to evaluate (n) plus 8.9 for n equals a -2.3. So all you're going to do is plug in the -2.3 for n. So what your problem should look like, and when you're doing your work, I want to see this. I'm bringing down the negative I've already been given, and now I bring down -2.3 in parentheses plus 8.9. Okay, hopefully most of you remember this rule from last year. This is basically multiplication, a negative times a negative, which we're going to be talking more about in our next lesson. But you should remember negative times a negative is always positive when these are side by side like that. So we end up with a positive 2.3. Now I can drop my parentheses because I've simplified what I needed to, plus 8.9. And when I simplify that further, I end up with 11.2. Example 5 is just looking at application, just a real life situation that uses integers. So it says a rock climber starts at base 132 feet below sea level. And they want you to write an expression that can show this climber climbing. I'm going to read you exactly what they said in the book because I usually will take these and simplify them when we write them down. It says a rock climber climbs a mountain that has a base 132 feet below sea level. Write an expression to represent the climber's height below or above sea level. So first of all, you have to come up with a variable. So stop and think about a variable and always label your variables. So find a variable or decide on a variable. And label it. That way I know, you know, everyone knows what you did. So if we look at this, we're talking about the climber's height. So our climber's height could be hopefully some of you thought about something like H for height. So I'm going to go ahead and use H. You might have used C for climber, but I like that it's referring to the height. So we know that it's starting below sea level by 132. So what you have to think about is, if you had a picture, you always want to use pictures if you need to. And if I was to draw my picture, here's sea level. I'm thinking about that, and the climber is below sea level by 132. So it represents a negative 132. Couple ways that you could come up with this expression, but what I'm going to be thinking about is the climber's height, how much they've climbed, H, adding the negative 132. So you have a couple different ways that this could be. You could have H plus a negative 132, and that's always going to balance out to whatever height they're currently at. You could have a negative 132 plus H, that's the commutative property allowing these to move around, still the same answer. Okay, for part B, now that you've come up with your expression, they're actually going to give you more information so that you can think about an equation and actually solve for some information. So in part B, they say find the climber's height above sea level at 485 feet above the base of the mountain. So this is where sometimes it's really nice to have a picture, because it's easy to confuse these. But if you think about it, what I did on my picture is I just added the base, because remember the base was 132 feet below sea level. So here's my base at the bottom, there's my below sea level part. Now they're asking to find the climber's height above sea level at 485 feet above the base. So what we're actually looking at is the climber climbing 485 feet. And this is the height of the climber. Height of the climber goes with our H, so we're actually going to evaluate and plug that in for H. So when you evaluate and plug that in for H, you have the 485 feet the climber already climbed, plus that negative 132 feet that was already below sea level. That's going to give you this part, which is how much the climber climbs above sea level. Opposite signs, so I find the difference between these. Always use your larger absolute value number when you go find your difference. Oops, and I don't know why I put plus, because I was looking there. So we're actually going to find a difference. So we have a difference of 353. Here's our positive is our larger absolute value. So the answer is the climber is 353 feet above sea level. And I always want you to answer these questions in words explaining what you just answered. That's the end of lesson 1.4. Now go ahead and start lesson 1.5.